Now, Dr. Arun Kumar to felicitate Dr. Deven Singh ji.
അത് ഓപ്പൺ ചെയ്ത് വെക്കണമല്ലോ വിൻഡോ ഡെസ്ക്ടോപ്പിൽ ഓപ്പൺ ചെയ്ത് വെച്ചാൽ മാത്രമേ അത് കിട്ടുള്ളൂ. അങ്ങനെ ചെയ്യണം. അല്ലെങ്കിൽ എന്റെ വിൻഡോ
അത്
വേണ്ട ക്ലോസ് ചെയ്യുന്നുണ്ടാവും. അത് ഓപ്പൺ ചെയ്യും. മിനിമൈസ് ചെയ്ത് ഓപ്പൺ ചെയ്ത് വെക്കാം. വിൻഡോ വിൻഡോ
വരുന്നില്ലാതാണ് സമയമെടുത്തായിരിക്കും അത്.
Thank you. Now I'll take the permission of chair to let the lecture start. Thank you, sir.
ഓപ്പൺ ചെയ്യും.
Professor Venu Gopalan,
ഇവിടെ വരും.
are you listening? Yes.
Hello, can you hear me?
Yeah, you are audible, sir.
Okay.
Share your slide, please.
Are you able to see my
Yeah, your slides as well as you both are.
Modulation like that.
Pardon, sir?
Are you able to see my screen?
Yeah, your slides are visible and you are also visible, sir. Your voice is also clear.
Wonderful. Yeah. Shall I start then?
Yes, sir. Start.
Is the audience there?
Yes, sir. Audience are there.
Okay. Thank you.
Thank you, sir.
It is for about half an hour. Is it not? Yeah.
Yes, sir.
So, thank you, Jitendra and the organizers for calling me for a invited lecture. It is my pleasure to be in front of you to talk about supramolecular synthesis modulation in crystal engineering, a structural outlook in ICMACS-2024. Of course, at this afternoon, I don't have great expectations that I will make you pedantic after this lecture. Nevertheless, I have certain simple objectives of telling you what is a crystal engineering. It will be interesting for the people, those who are novices in the field, to know what is crystal engineering. Of course, you are well aware of other branches of engineering like civil engineering, mechanical engineering. Everybody knows how it is. But what is crystal engineering and what is a structural outlook based upon crystal engineering will be interesting to all of you. Let me go directly to the topic. Everybody look forward for a clear and well-defined definition of a field or a sub-branch, and here is what I am showing you. Crystal engineering is the study of the systematic architecture of crystal structures and the utilization of such knowledge in the design of new solids with desired chemical and physical properties. Of course, you will be well aware that there is some color codes standing here. Architecture and crystal structures are in yellow, and desired properties are almost in red. I have put this with a well-defined idea in my mind that desired property is something we look forward. We want always things to be good, be it a fan, be it a car, be it a jet plane, be it a house. We want something to be good, something to be perfect, something is useful for years for coming together. And how do we achieve this? How do we get desired properties? In this thing, we look at the architecture of crystal structures for certain desired properties,
Hello,
the
sir.
utilization of such knowledge in the design of new solids. So we want some new solids with desired chemical and physical properties. So what is my aim in next 15 minutes? My aim is very simple. I just wanted to tell you what is crystal engineering. Okay, let me go. So let us go crystal engineering. So this is I am showing you three house. This is a house. This is a house. This is another house.
Excuse me, sir. Pardon me. Actually, your slides are not moving, sir. It is still showing the first slide only.
Is it?
Yes, sir. It is only the introduction, first slide only it is showing.
But here I am able to have gone to the third one. Okay.
You just share the slide, sir. Otherwise, if you allow me, I can share from my side.
Let me try once again. Is that well? Or is that fine?
Yes, sir. You try once.
Why it is not coming? You are not able to see my slides, is it?
No, I'm seeing your slide, but your slides. Yes, now it is transitioning. Yes.
Is it moving now?
Now it is moving. Yes, sir.
But that is not in
Hello?
presentation mode. That is the problem. Let me see.
Okay.
Hello. Sir, kindly.
Just give me a minute more. Okay, let me do something. Okay. Is it moving now?
No, sir.
Not moving. Okay.
Now
if
it
I
is
if
moving.
I go this
No.
way, oh, then no, this is having I cannot go this way because this is having a lot of animations. How do I do it? Stop presenting. Let me try some other. I just don't understand.
If you allow, we have already downloaded the slides, so we can share from our end.
Yeah, that we will do. Just give me one more minute, Jitendra.
Sure,
Anyway, I will reduce my thing, but give me a minute.
Sure, sir.
Now this way it is. Let me see. No, this is not okay. Let me ask. Just stop. Vijayan, the slide moving in Vijayan. Just hold on once again. അതൊന്നാലും മൂവ് ചെയ്യുന്നില്ല അത് സ്ലൈഡ് എൻ്റെ സ്ക്രീൻ വിൻഡോ ഈ മൈക്രോസ്കോപ്പ് വരുന്നോണ്ടാണ്
Excuse me, sir. Can you see on the screen? We are sharing the slides.
Is that yeah are you able to see a screen?
We are sharing the slides. Can you just confirm if you are able to see the screen? Then we can move as per your instruction.
it is the first page. Okay, come to the second slide. Yeah.
Yeah.
But how do I move it?
You just say next, we will move, sir.
Okay, but that will not work. This is in my hand. I have to do it myself.
No, no,
Okay,
no.
let us go ahead. Okay, go ahead.
You
Next
just
one.
speak, sir. Whenever you want next slide, we will move the next slide as per your instructions.
Okay, okay, next. Okay, let me. Are you able to see there the screen?
Yes, sir.
Okay. Okay, let me start. So this is. So we talked about crystal engineering. So it is systematics of the crystal architecture. You are able to see. You are able to see a house here, another one, and all the three are houses. Nevertheless, their architecture is very different. So next. So let us ask that in this way with Jitendra, my talk will not be effective at all. This much I am sure because it is in my hand whenever I wanted to click. So there is no who is an so now who is an engineer? Who is an engineer? Next. So we will go through a dictionary to know about the engineering aspects. So here it is written: engineering is an application of science to design, building, and use of mathematics, etc. You will be you there are 200 next. That is the problem. There are more than 200 next. So that is my problem, Jitendra. This is the thing.
I'm sir, this is the best I can do right now.
Yeah, right now. Let me.
Yeah, because there is some problem, so this is the best I can do.
Yeah. Okay, I will keep on telling you we will. So, friends, I'm sorry for all these interruptions. Something we changed the computer there. I am not in my control. That is why the talk will not have its flow. Nevertheless, my aim is very simple: to introduce to you what is a what is crystal engineering, this field, and to tell that I'm just bringing a simple concept: who is an engineer. And all of us know, if you do not know a meaning of a word, we'll go to a dictionary. So there I have opened the dictionary taken from the word from Oxford Dictionary. Engineering is application of science to design, building, and use of machines, etc. On the left side, you can see a building, and a civil engineer is making a building. On the right side, there's a mechanical engineering, etc. He's doing his work. Next. Yeah. So now I would like to show you something interesting. See, science inspires naturally artists, and artists inspire scientists. Here is a cartoon I have taken. How do we inspire each other? Scientists and artists, how do they inspire each other? Here is an unemployed engineer attending an interview. He's telling, so tell me, what are your hobbies? Searching for a job. This is what our poor man is talking. Here is another. It is my design. Unless it falls down, then it is yours. So what is happening is this civil engineering. This is human mentality. If something works, it is mine. If it doesn't work, it is your problem. Then it is yours. If it works, it is mine. So I just wanted to tell you this idea. This thing is that we inspire each other. Artists inspire scientists. Scientists inspire artists, cartoonists, etc., etc. Even an engineer can inspire an artist. Next. And what is his or her job? All of us know what an engineer does. And next. And he constructs trains, he builds boilers, he designs, etc. And here is another cartoon I have taken from you. This little girl says, the parent says, she says she wants to be an engineer. Isn't that cute? Then the little girl says, let us see, you call me cute when I have built a few missiles. So this is the way it is interesting. Next, go next please. Next slide. Yeah. Here is engineer who manufactures chemical. Now, next is who is a chemical engineering. We are going back to, we are slowly reaching to chemistry. Okay. So next we are telling one slide before. One slide before.
पिछला slide.
Previous slide. Yeah. Here is then engineer to chemical engineer. Okay. Here is a chemical engineer who manufactures chemicals, a chemist who works in a factory, or even a glorified plumber with an exclamation. This is a chemical engineer. Next, please. Now, who is a crystal engineering? Crystal engineer. This is our crux. I wanted to introduce to you who is a crystal engineer. If this is a brick, the top one, we can get a wall like that. The next one, are you able to see my arrow? No. Anyway, if this is a brick, we'll be able to make another different wall like that. Similarly, if this is SiO2, we are going to get quartz crystals. If this is water, we are going to get ice flakes. This is hemoglobin, we are going to get hemoglobin crystals. So next. Nature is the best designer. He can also engineer molecules to pack in pre-designed way. The question is, can we design molecules to arrange in pre-designed way? The way we human beings can design different kinds of walls. Can we tell the molecule, or can we pre-plan the molecules to arrange in a predefined way so that we get a different molecular arrangement? This is a pertinent question, and a crystal engineering deals with such ideas. Next, please. So, in this way, so what is the thought process? The thought process is that, like a wall, when we arrange, we get different types. If we arrange molecules in a pre-designed way, can we get desired properties? A field slowly develops, large number of people do the research work, and books start coming, reviews coming. For example, review article in M.L.K came, a crystal engineering, a textbook came from Desiraju and Luke, another book came, crystal engineering. Then themed issues came, crystal engineering and crystallography in pharmaceutical chemistry. And in New Journal of Chemistry, a themed issue came, and afterwards new journals came. The first journal, American Chemical Society's Crystal Growth and Design, came 2001. Crystal Engineering and Communication came in 1999. That is around 25 years before. So, around 25 years before, new journals started coming up, thematic issues started coming, books started appearing, and review articles coming in papers. This way, a new field start emerging. Next one. Next slide. Yeah. See, the Gordon Research is a benchmark for a field. Gordon Research Conferences. This is a conference happened in 2010, in June 6 to 11, 2010. So, a new field like a civil engineering or mechanical engineering, a new field starts appearing with journals, review articles, compendium of knowledge, large number of papers, etc., etc. A field called crystal engineering. So next. Now let us go back to the very definition I told in the beginning. Crystal engineering essentially involves the study of systematic architecture of crystal structures and utilization of such knowledge in the design of new solids with desired and physical and chemical properties. So for students, if you simply see, we don't want a long definition. If you simply say what is crystal engineering, it is a field, it is a branch that deals with crystals, where we engineer the molecules to pack in pre-designed ways in a specific way, get desired properties. Next. So of course, when we are packing a wall, we need different type of cement to pack them. Now, when we pack the molecules, when we wanted to arrange the molecule, we need a molecular glue. So this molecular glue, this cement, here we want glue means a paste to stick something. We use intermolecular interactions. Next. In this context, let us ask a question. How much 10 gram of carbon cost? 2 rupees or 2 lakh rupees? Next. Sure, it depends. If it is on the left side of this beautiful girl's neck, on a necklace, it is going to be that way. On the right hand side, you can see a pencil. So that costs maybe 2 rupees or one, I don't know, even 50 paise. There it may be 5 lakh rupees. What is the difference? It's the same for us, the same thing, pure carbon. One is, and you know, graphite versus diamond, their properties, their differences, everything is well aware of all of even novices in chemistry. So because of that, it is, I don't want to dwell upon more on this because the arrangement of the atoms are different, the packing is different, the properties are different. Next. So this way, in the molecular world, in the atomic world, we call it allotropism. In the molecular world, we call it polymorphism. So crystal engineering is a very important in polymorphism. So what is the concept? The concept is very simple. Atoms can pack in different ways in solid. A typical example being graphite or a diamond. In a similar way, even molecules can also pack. Molecules can also arrange in different ways. This is called polymorphism. And this arrangement can have different properties. So crystal engineering is very important in polymorphism and pharmaceutical drugs. Of course, you know pharmaceutical drugs are very, very important. Next one. Let us ask with one more example. Look at this compound. All of you would have used this compound at least once in your lifetime. This is our famous paracetamol. Look at the amount of paracetamol produced. This time of tens, 1.15 thousand tons of paracetamol is produced per year in the world, and it arranges in two different ways. On the left side, you can see forms table 1, forms table 2. When you form is metastable 1. When you go to the market, when you go to the medical shop, maybe 100 meters away from you, you will going to buy only one of the molecular arrangement. Okay, that is the commercial form 1. So what is my idea? I want to tell you, molecules can arrange in their solid state in different ways. Their properties are different. The one which is having more desired property we will use. A typical example is our paracetamol, and which is available. So this property called polymorphism is extremely important in normal life, and this is a part of crystal engineering. So again, once again, just for novice, a simple man's definition, what is crystal engineering? It deals with the arrangement of atoms, molecules, or ions in the solid state in a desired way to get a desired packing and with physical and chemical properties which are useful for mankind, useful for us. Of course, we do not know whether it will be useful or not. That is the way research emanates. Research comes that way. Next one, please. Can we control polymorphism? Then we'll ask. Next question is, can we control? Bigger question is, can we control crystal packing? Okay. Next. Yes. You can see molecules arranged to become a supermolecule, and a periodic way of supermolecule arranges. Next behind is called a carboxylic acid, which is bonded by a dimer of carboxylic acid, which is arranged by a synthen, carboxylic acid dimer synthen, which you can see this is benzoic acid. Instead of benzoic acid, if you use adipic acid, it is going to be that hydrocarbon chain 1, 2, 3, 4 hydrocarbon chain is only a simple space. So as adipic acid polymer also arranges in the same way as benzoic acid. So this I'm going to introduce another word here now, supramolecular synthesis. So this way of arrangement of a molecule is called supramolecular synthesis, where you can see on the left side the carboxylic acid dimer synthesis. Supramolecular syntheses are structural units within supermolecules which can be formed and or assembled by known or conceivable synthetic operations involving intermolecular interactions. This is the proper definition. Crystal engineering, we showed a proper definition. I mean, accepted definition, supramolecular synthesis. So, for students, for you to arrange what is a next one. Next, yeah. Here. So, what is a supramolecular synthesis? It is very simple. Molecules arranged in crystals in different ways. And to arrange this, they use a molecular group called intermolecular interactions. These intermolecular interactions operate in very different ways in different functional groups. Number one is a carboxylic acid arrangement of a dimer arrangement of carboxylic acid. Another number two in here, I am able to show that is in what is it called, amide. Okay, the alcohol, amide, even halogens, etc., etc. There are so many of them. 16 of them I have shown here. Molecules packed using this type of intermolecular synthesis. This intermolecular association, which is repeated, recurring, and robust in the crystal state. Now the question, this is called a supramolecular synthesis. We have seen the super definition. How did we stumble upon a supramolecular synthesis? Can I take 5 more minutes more?
Yes, sure, sir.
Yeah, I will. So the question is that how did we stumble upon a supramolecular synthesis? You can see here that this is a dialdehyde. This dialdehyde upon UV light, upon shining light, it becomes dark red. The left side is colorless, right side is red. How does it happen? This happens because I have a lot of constraints because of our mouse is not working, things like that. Doesn't matter. Anyway, what is important here? Here is a compound which is a dialdehyde, which is colorless, and upon shining light it become deep red. And we analyzed why it is the reason, and we found that, as is shown on the left side, there is a CHO hydrogen bond, where with some dots you can see here. I am shaking my mouse, but you may not be able to see that. There is a with a red one, O2, there is some bond. Next one. We took some other there are about 22 molecules we analyzed. In all of them, when it become colored compound from colorless, this property called protochromism. In controlling the protochromism, this type of arrangement is very, very important. That is the molecular holding tight. That is locking the molecular conformation in a desired way is very important to induce photochromism. And what is important here is that the way I have shown you some bonding pattern. Next. So when we studied about these 20 structures, you can see on a circle, we found that a molecular arrangement which is like in the bottom I have written synthon 1. You can see 1, 2, 3, 4 of them. 4 of their arrangement is through CHO hydrogen bond. There is a hydrogen bond I have shown. So I say 4-pronged hydrogen bond. This type of recurring molecular association, if it occurs in many crystals, we call it a supramolecular synthesis. So are we hitting upon a synthesis? Next one. How do we know this? So other polymorphs, this compound are 2 polymorphs, polymorph 1 and polymorph 2. Other polymorphs, next slide please. It is not having that, it's a triclinium module, not having that synthesis at all. Now what is a synthesis for us? For that 4-pronged arrangement. Next slide. Yeah, this 4-pronged arrangement, you can see 1, 2, 3, 4 lines. This is called a supramolecular synthesis. To give the status of a supramolecular synthesis, what should we have? This should happen in many crystals. it should control the packing of many molecules. Then only we can call it as a supramolecular synthesis. That is, I have written, how do we believe that it is supramolecular synthesis? How are we sure that this is a supramolecular synthesis? Next slide. If it is so, if look at this molecule. So what is one side OCH3, another side aldehyde. So you can see the two arrows from this left side as well as the right side. So if this is the arrangement, we should get a molecular tape in the crystals in this way. You can see that the way it is arranged here. Indeed, when we synthesize and we study the structure, this way of arrangement we find the toppermost. Now look at the bottom. That is, if this molecule also arranges the same way, we should get a linear tape. Okay, of course, we are getting that one also. Next slide. So, okay, next slide, please. So, what is happening is that we studied large number of structures. From these large number of structures, we found that if there is no other competing intermolecular interaction occurring, then we are going to get this synthesis, this four-pronged arrangement. Okay, let us go to next slide, please. I will stop in 3 minutes now. Yeah, if that is the case, you can see on the right top corner, synthesis 1, the four-pronged assembly in our human language, and telling hydrogen bonding that way. So, for the synthesis survival, we don't need much other interactions. If that is the case, look at molecule number 1, 2, 3, up to 6 molecules we synthesized. And if that is the case, we should get the molecular arrangement manifested in the crystal structures. Next slide, please. Exactly that what happened. You look at the way, if that molecule on the right hand top corner, that is the way we should get an arrangement, the way linear tape. If the molecule number 2 is having a kink on its structure, so it should arrange like a staircase where you can see the kink here also. This molecule, which I wrote short step staircase, is like the molecule number 3, where you can see CH2, which is like a step there. It should manifest as a short step staircase, which is exactly what is happening. Number 5 and 6 did not work. They did not crystallize at all. So what are we finding here? We are thinking that a molecular association pattern is possible, and when we synthesize such molecule, we are going to get a different arrangement of the molecules. Next slide, please. Yeah. So one more next slide, please. So what happens is that if we change from the left side to right side, we are going to get another synthesis, and it is possible to make, by modifying the first synthesis, supramolecular synthesis, we are going to be able to make a synthesis number 2. And if we design large number of molecules, we will be able to make this synthesis manifest in the solid state. Around 30-35 structures and around 20 papers are there manifesting this synthesis. So let me conclude here in a simple. Meanwhile, Jitendra, you can go to the last slide. Let me conclude at this. I think I have taken 20-25 minutes. Is that okay? I can keep on talking, but I think if other speakers are there, 25 minutes is good enough. Hello, Sidendra, are you able to hear me? Okay. Last slide, please now. Last slide.
Yes, sir, we are moving.
Yeah. You can come out of it and go back to the last one. That will be better. So let me talk. Let me tell. So what was my interest? My interest was to tell what is crystal engineering. So crystal engineering is a new field in material sciences, where we arrange the molecules to get desired packing, so that we get some properties manifested. Second concept I want to taught is that for this packing, intermolecular interactions are very, very important. They manifest as supramolecular synthesis. We have done, stop here. We have done 2 supramolecular synthesis. Now what I am going to show is that what are you seeing on the screen? You are seeing using a vegetables and fruits, we have made a design. This design looks like a human being. Not only human being, I'm sure you will be telling that even the gender is inscribed on the structure. The gender is that it's a male. Look at this structure. See, we human beings with our intuitive ability able to think that here is a man, though looks funny way, is a man coming from vegetables and fruit. Will a goat bakris look at this as a human being? Nobody knows. So the question is, the philosophy is that he is whole greater than the sum of the parts. So what is the link here? When molecules associate together, like vegetables and fruits associate together, it manifests in a different way like a fruit. Here, the whole is greater than the sum of the parts. So crystal engineering has this theme, its background. That is, when molecules come together, when molecules arrange together, new properties, new materials, new measurable things manifest, just like the way I have shown you here. Next slide, please. Yeah, I would like to place my acknowledgement for my teachers and my collaborators here, and thank you for your patient hearing. I could have done much in a different way altogether, covering more things, but technology sometimes fails. Thank you everyone for a patient hearing. Thank you very much.
Thank you, Professor, for a very nice and informative talk.
Thank you.
And
If there is a
let's thanks,
question,
Professor.
I'll be happy
Another
to
round
answer.
of applause, please.
It's finished.
To the audience, if there is any question, you please ask. Venu sir, can you hear me? Okay, I think he left. So thanks. Let's thank him for his nice talk.
The most respected Professor Saroj Kumar Shukla ji. I would like to invite him on the stage. I would like to invite Dr. Amit Kumar Verma to felicitate Professor Shukla ji. लगा रहने दीजिए लगा है मैं Professor Saroj Kumar Shukla ji has done his MSc and PhD from Deen Dayal Upadhyay, Gorakhpur University, Gorakhpur. He has published approximately 98 research papers in reputed journals. He has edited a book entitled Advanced Carbon Materials and Technology, John Bille. Dr. Shukla has also visited several countries like Japan, South Africa, Turkey, Thailand for different academic programs. He is member of editorial boards of various journals. He has been awarded with different national and international awards for his scientific contributions. Currently working as associate professor in the Bhaskaracharya College of Applied Sciences in University of Delhi, India. The title of today's talk is Chemically Functionalized Electrically Conducting Biopolymer Nanocomposite for Sensing Sciences. Professor Shukla, sir. Chair.
Thank you, Honorable Organizer of this conference, Chairperson of this session, and all the office bearer of this college for giving me opportunity to share my view of the research findings with you people. I will fail my duty if I will not acknowledge the invitation of Dr. Sunil Mishra, whom I first time have conversation online, and really I am happy, sir, for inviting me. In morning we have listened different part of chemistry. So this is the this one, this one. We have already listened different part of chemistry and its application. If you see the all the development of society, two part is very important. One is energy and second is the water. All the scientific, non-scientific development are centered around two things, water and energy. And in between both, material plays a crucial role to have a dialogues for different kinds of interconversion and different kinds of dialogues. Materials have been the backbone of all the developments, not today, in the post-BC and everything. One of the material is the polymer. Although we familiar about the polymer since the beginning of the life, just to our back one of the speaker tell about the, I think Professor Nizamuddin sir tell us that science start from the polymerization by simply the polymerization ammonia and ammonia, water and the carbon dioxide give rise to polynucleotide, and this is the big burn of the our nucleic acid from where life start. And all the our biological system are full of the polymers and we use it in very different types. But if this is one aspect, second aspect of polymer, it is the only 100-year-old materials. It was first time established. Sir, can you give the second slide? Second slide. This is 1920. This gentleman have proved that the two molecule can be joined with each other in a covalent molecule. So we can have a bigger molecule and it was known as macromolecule. And with this simple analogy as findings about the macromolecules, a huge spectrum of material synthesis started by combining two monomers which we call molecules, but only difference of monomer and molecules, that molecules have a single functionality, but if a molecule has a bifunctionality, it can be used as a polymer. Sir, next please. So this is the just a milestone of polymer science. First polymer was synthesized by in the form of bakelite. Then Carothers is one of the very significant contributors in the development of polymer science and who synthesized the nylon, which was called as artificial silk. And nylon was a compound who plays a crucial role to win the Second World War by the Americans, because all the parachutes and other things was made from the nylon. Later on, different types of historical developments that took place, and polymer established as one of the most fascinating material that which has ability to substitute ceramic, wood, silk and all the things. And if you have a mind in every corner of your city or big or whole, at least more than 70% things you will find which are made up of the polymers. Or you can say only one hope of the societal development is the polymer. And before the 1970, the polymer was only used as structural material for making the automobile part, the chair we are sitting, we can make our cloths, we are making the cassettes, all the things. We call it a structural part. Why it was a structural part? Because when we have a polymer, polymer consumes its monomer and its functionality has been lost. So because of these single properties, polymers are considered as a neutral molecule or chemically inert molecule which doesn't have chemical stability. Since they are chemicals, every kinds of permutation and combination are possible to modify these polymers. So first time, one of the scientists, one of the three groups, Allen, Heger and Shirakawa, they were working on the polymerization of the acetylene, and by mistake they have added a huge amount of iodine, and they find that iodine, polyacetylene, which was having a different color, they got it the silvery colors, and from there a new turn in this science has been started that polymer can have a conductivity which was initially it was the not. So by chemical modification and development of the conductivity, these two synergistic effect boost up this material in a different kinds of application by which promises to supply the materials all kinds of things. You can talk about electronics, you can talk about the biomedical devices, you can talk about your space specification. Everywhere this material has a promise to serve the society for different application. Sir, please. This is the simply different types of polymer. Student can note down. Sir, please. I have already discussed it that this is the different stages of the application of polymer. In first step, beginning of human exploitation by the natural polymer, cellulose and rubber, but it was only the demand of Americans which have they used for ivory for different pieces, and they have killed so much animals. So to save them, when they have cellulose, they converted to cellulose acetate. It takes the shape of the processing, and from there later on people started to make the balls and other application. And in second stage, what happens? A tenfold of polymers have been synthesized, and which was commercially different application. In third stage, which we have working on this time, that they functionalize the polymer for evolution of the new properties along with the chemical stability and natural polymer in the backbone of the polymer chain. How we can develop functionality? These are the different simple application by which we can develop the functionality in the polymer: grafting, doping, dimensional alignment. One of the example which was previously speakers has followed it by the that if you have a diamond and graphite, even you can talk about later, you can talk about graphene, carbon nanotubes, all are simply nothing, there is a dimensional alignment. If you know, okay, diamond has a three-dimensional bonding. If you cut one dimension, one electron has been free, it requires the conductivity. So dimensional alignment is a very important thing in the material engineering, just previous speaker has been pointed out. And composite and blending. Composite means if you add some another materials in the polymer matrix, and blending is a physical mixture. You can have two mixture, laminates. You can see the laminates are best example. Our plyboards are best example of these things. So next please. So when we functionalize this material, it explores these different kinds of application. What I tell, it can act as a active, it can act as a passive, it can act as a radiative. Active means which have some activity. For example, some people talk about your drug delivery. You know, we are just first speaker we have pointed out, if we are taking a medicine, only 7.8% medicine we are consuming. Rest are the useless. If you are taking so much medicine, it has a very adverse on your body. So this is important thing. So if you have ability to targeted drug delivery, only the defected cell you supply the active pharmaceutical active ingredient, you save a many part. So active means this kind of which have some responsiveness, some activity. Second thing, passive. Passive means like a control is on a structural part. And radiative means it can put something, generate some radiations. You can talk about our fluorescence, phosphorescence, these kinds of application which was explored by simply if you functionalize a polymer, how we can functionalize the student, we can, I have already discussed 3-4 topics in the previous slides. Sir, next please.
Please.
Yeah.
Please.
I am taking the first examples of this. Sir, can I start? People are discussing, so I thought maybe. So I have already discussed about the polymer can synthesize, and polymer is present in the nature. Rubber is the best example. Cellulose is the best example. Starch is the best example which you are using it. But they all have some limitation. I tell about ki cellulose can, if you make the cellulose acetate, you have a film forming ability. If you have cellulose nitrate, different kinds of ability. And cellulose is a polymer which is abundantly available in the nature in different biomass. आप घास से उठा के पेड़ की छाल कहीं भी लेंगे, सब जगह सेलुलोज है. And not only so, many very active ingredients, very important pharmaceutical ingredients are available there. So our one of the speaker talk about waste to wealth conversion. India government has a very promising application, waste to wealth conversion or circular economy. So what we did it, we take the rice husk means simple धान की भूसी का जो छिलका होता है. If you see other the covers of the grains, we can eat. But rice husk is having a plenty of silica. So it is not digestible. We cannot allow to eat our animals. So it is more like waste, but it contains several important ingredients: cellulose, hemicellulose, silica, other things. So what we have taken the cellulose and we treated with the alkali. So alkali treated with silica contains mainly silica and the cellulose. So silica got converted sodium silicate and cellulose is different. So there is precipitate, another the liquid. So you can separate the silica in the other part. So here we are having the I discussed it about, we mix with the other thing for application. But here purpose is we can separate these two materials and both the materials are having their own application. Sir, next please. Yeah. I talk about functionality. So let us come on the functionality. We have taken the cellulose, and what we did, we put some sodium carbonate. So carbonate, sulfates, nitrates, basic science, they are stronger ions than hydroxides. So some of the hydroxide got replaced by the carbonate. It was discussed about the previous speakers. I don't know something talk about the LED. He was replacing something there. It is replaced. But one thing important, what is the degree of substitution? कितने degree of substitution? That's a very important area. So if we have substituted, it contains carbonated cellulose. So cellulose is very important for packaging material. Paper to bark all are packaging material. So if we have a paper pack, how will make a paper pack? We take the cellulose and put on the polyvinyl alcohol. Polyvinyl alcohol is a polymer which is biodegradable as is water soluble. You screen all the polymers. One polymer, polyvinyl alcohol, which is water soluble and readily water soluble. No need to anything. And put some carbonated cellulose. It have a polyvinyl alcohol, cellulose, papers, and you can wrap it. Positive point, it have carbonate ions. Student, you have tested carbonate. How you tested carbonate? If some acid come in the contact of carbonate, carbon dioxide will releases. And the presence of carbon dioxide is an important thing. It doesn't allow to microbes. Microbial inhibition power in carbonate is very excellent. So we have a cellulose containing PBA matrix from the carbonate ion. So if we make a packet, I have taken the meat packet. You can packet anything. When these things are going to be spoiled, कोई चीज सड़ के खट्टी होती है, खट्टी में से एसिड निकलता है. And when we start acidifying, it indicator of the rotting or exploitation or spoiling of your organism. So whenever the acid generate, it releases, it come in the contact of this carbonate and carbon dioxide is going to be released. So the release of carbon dioxide is going to suppress the microbial growth. So it means you can use this polymer packet in a better manner with a long time storage capacity with the extended shelf life of meat packets or any packaging material. So we call it active packaging material. How we develop it? By functionalizing the cellulose which we have extracted from the rice husk. I am sharing those faculty, I am sharing only those my findings which are very cheap and readily one can do it in a normal level. I have shown you some devices which have only an investment of 1,000 to 5,000, not more than that. This I assure you. Next, please, sir. Yeah, another application which I tell about you, cellulose when we modify it, it become acid responsive. So you can see I have taken the UV cut, when it come in the acid, it have been blue shifted. Means its wavelength is going to be higher. So when wavelength is going to be higher, students, what happens? It means bonding is going to be poor. किसी भी bond की अगर wavelength ज़्यादा हो गई तो उसकी energy कम होती है. तो it is going to be matrix the loose. Matrix उसकी थोड़ी टूट गई. And what happens? If it is loosening, it has a more dissolution power. So similarly, what we did it, we have taken this and put it here this simply calcium supplement, which we have taken by many girls and many boys ले calcium sulfate, Cell-Cal, हम सभी लोग खाते हैं. We have packed it and we have tested how it is going to release it. So we find that because of this acid treatment, it has ability to release in a acidic conditions. Where is acidic? In a directional release, it can be possible. How we do it? We know it because our entire body is having different type system, but assimilation part is taken by stomach or the intestine. So if it is going to release it there, the assimilation will better. Although we have not done for the biological system, but we have tested in the laboratory skills. So we have used this cellulose, we have derived from the rices for the targeted drug delivery as a model of this application. Please. And now let us come on the sensor. What is sensor? Which respond to something. हमारे आँख के सामने कोई आता है, दिखते हैं कि दिख रहा है. इट्स अ बेस्ट एग्जाम्पल ऑफ सेंसर. आपके हाथ में सुई चुभा है, आप डाल लीजिए, प्रेशर कर. आपके हाथ को आपको दर्द सेंसर. So these are the body has a 5 sense organs, and these all the sense organ are copied by the engineers for different applications. So we have taken the polymers, functionalize it, and we have used as a transducer. Transducer means which transfer the one energy in another form. So similarly, if you take it the polymers and apply the some electrical perturbation, some electrical signal will appear. If you apply some optical perturbation, some optical property, I say radiative, I talk about the something about your generation of light, photoresponsive and other thing. Mechanical, thermal and gravimetric sensor. So these are the different kinds of sensor which we can use by using the chemically functionalized polymers. Why I have taken the polymers? Because कमरा बहुत बड़ा है, इसको किसी तरीके से डेकोरेट कर सकते हो. अगर कमरा छोटा होगा तो आपकी perturbation combination की possibilities कम हो जाती है. So polymer is a long chain. You have a multiple functionality which you are not able to do till time. Okay. So these are the different sensing application. These are the types of sensor. This is the sensing application. Talk about ammonia. This we have done it. I will discuss all about it. Sir, please. Yeah. This is the first examples optical sensor which we have monitored it. You can see this is simply a glass chamber where we have put the previous one. Yeah. You can see here I have a helium neon laser and a simple glass tube which we have coated with some materials. The materials is having ability to interact with the any light. And here you put the helium neon laser. If you don't have helium laser, you can use simply your pointer or any. You can use it pointer. And the light which is coming out from there, you can monitor it. And simple example, I put it the saturated salt solution to control the humidity of the chamber. And yeah, so here you put the saturated salt solution. What is purpose of saturated salt solution? To control the humidity of this chamber and put the temperature and hygrometer. Sir, please next. So as we increase the humidity, the light which is coming out, it is going to be increased. So just you can put the optimization, ki what is the humidity and which level of light is coming out. Calibrating, you can find out the level of humidity in the atmosphere. Humidity monitoring is not a very important thing. Ki people has done a very lot. If you see, last one BCs, people put it the charcoal and allowed to absorb the water molecule by Chinese peoples to what amount of water has been absorbed. On that basis, they predict the rain conditions. But current times, the application of humidity is going to take a different dimension. So please. Yeah, earlier it was I am talking about the different kinds of sensor. One sensor, this is the electrochemical sensor. How it is different? We make the simply film of this polymer and we connect the multimeter. And it is simply a glass chamber. You can take a container, anything, and put it in a saturated salt solution. Saturated salt solution means, if I am telling for a student which are sitting here, not for faculty because they are learned people. I don't want to undermine silly people. Saturated salt solution, if you put the lithium chloride, it creates absolutely anhydrous condition. If you make the saturated salt solution, potassium nitrate, it generates extremely high hygroscope, humid condition, 98, 99% humidity condition. So check it different kinds of humidity level you can maintain inside the salt solution. And earlier we measure the coming light output power, but here we are measuring the electrical impulse. What are the electrical impulse? Resistance, voltage, capacitance, you can change it. Why it happens? Because earlier polymer was non-conducting, but in 1977, the discovery of conducting polymer, it add a dimension or use this polymer in this aspect. Sir, please, next please. I have shared all this, yeah. So you can see, as we are increasing the humidity level, resistance is going to be decreased. So just measure what is the resistance at which humidity level you are in a position to find out the humidity of the surroundings. This is the simply polypyrrole coated cellulose. Same pictures, which is showing you that this is the polypyrrole, this is the cellulose. You can see how beautifully decorated on this cellulose. It indicates the functionalization of the polymer, and which polymer? Cellulose by polypyrrole. Sir, please next. These are the another few examples. I don't want to go to them. Please. Yeah. This is another important area which I have to share with this. I tell you, measuring humidity is not important, but application is important. In our important breathing pattern, our body condition is important parameter where we have to invest more money. आप you people remember कि आपको कोई बीमारी थी, आपके सांस में बदबू आती है. It's clear indication. You see, even आपके कहीं भी होगा, your composition is going to change. And same thing, आप ठंडे में अगर आप कहीं भाप निकालें तो आपके उसमें भाप निकलती दिखती है. Reason कि when you are inhaling, it is the dry air. If you are exhaling, it contains highly humid content. So there is difference between humidity level of inhaling and outhailing condition. So what this experiment we do it? We have coated this mask with a simple polymer and measure the resistance frequently. So as it is exhaled, resistance is going to change. As it is a inhaled, resistance is going to be changed. So by this transition, you can call clicking, whatever you can say, बढ़ने और घटने के ट्रांजिशन को अगर आप मॉनिटर करें, you can recognize the whether you are breathing in a normal condition, where you're breathing is an abnormal condition. So conditioning is going to be changed. So please. Yeah. One important thing, when our kidney is not going to be function properly, it releases ammonia. Yeah, our protein metabolize decides the ammonia concentration in our breathing pattern. So we try to measure the amount of exhaled ammonia in the exhaled water by simply the ammonia concentration. You can see if it is ammonia level is more than that, it indicates that your kidney is not functioning well. So you can monitor the breathing pattern and you can monitor the ammonia level to pre-screening of our kidney function, and it can be extended further. Many people are doing as a portable device to have a breathing pattern or your health condition. So based on ammonia. So please. This is the simple design which you have measured. So please next. Yeah. We are from India is a country where economy is based on the agriculture.
5 minutes more.
And ammonia is an important part. What we did, we have taken the glass rod and coated it with the composite. And here you put the soil samples. We put the urea, and this urea can penetrate and release the ammonia. So this level, ammonia retaining capacity vary from time to time. So by this simply measuring this change in resistance, you are in a position to screen the urea retention time of this soil. So health nutrition indexing can be done by this experiment. So please next. These are the simple mechanism. Please next. Uh, skip करिए जाने दीजिए. Now I command the because time is not permitting. I don't. Skip कर दीजिए. This is simply an experiment which we have designed to check the presence of glucose in a fruits. Next please sir. By simply previous one. I want to spare 1 minute time. So glucose is having different kinds of culture now. So you can measure it and you can find out whether the fruit juices which you are taking from the market, does it contain sugar, glucose, or something artificial sweetener. So this portable device we have developed from our lab, which can screen the presence of glucose in a different kinds of juices. Sir, please. Again we are coming. This is the potentiometer, we measure it. We have taken 2 simple glass chamber 100 ml and one putting electrode and here putting the water. In this electrode, this chamber, we put the different kinds of metals and we measure the potential which is going to happen. All we know that metal is having oxidation reducing capacity. Once the oxide is used, they generate some potential. So potential generation is self-signal. It doesn't need external energy. So other devices need external energy, but here since it is generating self-energy, it doesn't need external energy. So that's why this is called self-powered cell. It doesn't need external sensing. So please next. So here we measure about the presence of copper in the materials. Please next. This is mechanism how we can graft functionalize polymers. Sir, next. Similarly, we have took some copper. We methyl parathion, different kinds of pesticides we are using, and they all present in our vegetables and fruits. We taking the soup and allow it, so potential is changing. So by simply using potential, you are in position to measure the concentration of MT means methyl parathion, which is the very common parasite pesticides which used by our farmers. So please. Next, this is again we have paracetamol. Next. Yeah, stop it. Now I need 2 to 3 minutes. Now I am scanning. Everybody has a different kinds of working philosophy. We are working also having some philosophy to satisfy our mindset, not for other mindset. People are measuring the presence of metals. We call labeled. Lead is a very harmful metal. Mercury is a very harmful metal. But are they harmful? It is harmful for you. But full of electronic industry is using cadmium mercury tellurides. All this. So you cannot, this is harmful. It's not suits for you. It's harmful. So what we did? We put the 3 electrode system. I don't know what. We put the 3 electrode system. One is the detection, other the extraction. So once this is going to be absorbed, we put it here and apply external energy. So this metal which was going to absorb during the sensing, it is going to dissolve. So here you propose the schematic of extractive potential sensing. You can sense and then you can extract it also. So this is the simple setup which we have added in the things. Next please. These are the simple examples of mercury and things. Next please. Next please, mercury. So this is sensing mechanism. I am leaving it here. PPT. You may see it later on. Please next. Uh, Next part I talk about the energy and water. I am talking about water treatment. Please come next. So water is a full of your pollution. These are the method how to remove it. So next please. Uh, we have added the methylene blue and removed it the simple adsorption. Next. Yeah, stop it. This is my last one, which I am to share it. You know, our sewage treatment is an important area of this country, and problem that our municipal bodies unable to treat it. And sorry to say, even our academic institutions are also pouring all the chemicals in the drain water. I don't know, sir, आपके वहाँ की क्या position है, but very poor system which I have noticed in my to recalculation, recirculation of our used chemical. So we have taken the topic is the microbial fuels. Our sewage contains human waste, which is organic part, and normally it's a polysaccharides. So we take the sewage water of my college and put it the polyaniline encapsulated electrode and maintain the pH and some E. coli. So what happens? This E. coli is going to decrease the microbial organic part present in the sewage and generate the current of this level. It is not good. 160 microampere and 0.65 millivolt. But possibility to combine and increase the potential is there. So you can degrade the microbial fuel cell, generate the some current, and after degrading the organic part. So next please. Yeah. So you can see it here. This is
Sir.
our design setup. We put it
Sir.
here. I'm last slide.
Time up.
Last slide. If you see, I can just stop it. No, sir. I continue. So, a semi-treated slide water, we put it again the adsorbent. This adsorbent is the carbon rises we have used it. So, by this way, you are in a position to semi-treat our sewage water of my own college. Next, please. Yeah. So, these are the potential application generated in the polymer after functionality. Please, next. And last, I wish to thank the financial supporting body, whatever they have granted, my colleagues for providing infrastructure, the collaborator and co-workers for input and permitting me to present their work in front of you people. Next, sir. These are my some research paper. You can check it. Next, please. Once I like to thank you all for patience here.
Thank you, Professor, for nice and very informative talk on the functional polymers. House is open for question. If anybody has, can ask.
I will happy if a student will ask me any question.
Any student, you can ask any question.
Don't hesitate. Asking question is a first step to initiate your work.
Polymer is a very common material. आपका शैम्पू भी पॉलीमर है, आप उसी विषय में पूछ लीजिए।
पूछिए, खड़े होइए।
Okay, thanks, Professor. Then give him a round of applause.
Thank you, Shukla sir. और इस इंटरनेशनल कॉन्फ्रेंस की जो लास्ट इनवाइटेड टॉक है वो है डॉक्टर खेम बहादुर थापा सर की, जो भीमराव अम्बेडकर, बाबा साहेब भीमराव अम्बेडकर सेंट्रल यूनिवर्सिटी लखनऊ से हैं। मैं अंसारी सर को इनवाइट करता हूं डॉक्टर थापा सर के स्वागत के लिए। अंसारी सर।
Hello. Hello. Yes. Sir. Thank you.
Thank you, Ansari sir. Now I give very short introduction of Dr. K. Bahadur Thapa sir. He did his PG and PhD from PHU and IIT PHU respectively in 1998 and 2006. He has more than 59 publications in reputed journals. At present, he is working at Department of Physics, School for Physical Science, Baba Saheb Bhimrao Ambedkar Central University, Lucknow. The title of today's talk is Nanostructured Hyperbolic Metamaterials for Ultra High Speed Low Power Nano LCR Circuit, a Metatronic device. Over to you, sir.
Thank you, organizer, for inviting me this international conference. Today I am going to discuss some optical property of material. Generally, I am physics background means person. That's why there are some means chemistry only for nanostructure material. But what is there are some things that is going to discuss. That one is the nanostructure. Nanostructure, there are hyperbolic metamaterial, and ultra high speed, low power nano a Metatronic device. Okay. So first of all thing, what is hyperbolic? There are something is new. Only what is a LCR? You know, LCR one type circuits, and that but such type circuits are fabricated at nano level. Okay. So there are some things that is new. One thing is a Metatronic device. Well, first of all, I try to explain what is metamaterial, and after that we try to discuss about the hyperbolic metamaterial, and after that we discuss about the nanostructure hyperbolic metamaterial. And such a hyperbolic metamaterial generally used as a Metatronic device. Okay. So, what is metamaterial? Metamaterial generally is related with the optical property of material. Generally, I just जैसे मैंने ये चश्मा पहना हुआ है, this is a one type of means optical lens, and that optical lens is able to control the electromagnetic wave. एंड इलेक्ट्रोमैग्नेटिक वेव आप लोग ने बेसिक साइंस में पढ़ा होगा कि इलेक्ट्रोमैग्नेटिक वेव जब प्रोपोगेट करती है तो दे मीन सच इलेक्ट्रोमैग्नेटिक हैव द फील्ड वेव. वन इज द इलेक्ट्रिक फील्ड, अदर इज द मैग्नेटिक फील्ड, एंड प्रोपोगेट means propagation direction is perpendicular to the electric field and magnetic field. So that's why such type of electromagnetic wave can be controlled through the such type of glasses, and such glasses is the one type of that is a microstructure, micro material. But if what happen when we reduce the size of the such type of material, means if we reduce the such type size of material in the order of the microstructure as well as the nanostructure, that time what happens? So that is called one type of photonics, and such photonic material has the their property is negative of the refractive index. That is such type of metamaterial. So today we are going to discuss this photonics. Photonics is related with the metamaterial, and such metamaterial is used as this is a Metatronic devices, and such Metatronic devices is equivalent to this is a LCR circuit. Why we are discussing such type of material? Because if we are able to fabricate synthesize such type of material, that time we can reduce their power size as well as we increase their speed with the low energy state. So that's why. So in the outline of the talk is first of all we try to understand what is photonic crystal, and after that we will discuss about what is metamaterial and what is property of the metamaterial as subwavelength. What is mean by the subwavelength? Subwavelength means the structure of material must be lesser than their wavelength. Means इंसिडेंट wavelength से यदि उसकी साइज बहुत ही मीन्स जो साइज है वो साइज उस wavelength से बहुत ही छोटी हो तो उस समय हम इसको बोलते हैं सब wavelength. और ये सब वेवलेंथ मटेरियल को जब हम लोग फैब्रिकेट करने की कोशिश करते हैं नैनो ऑर्डर में, तो दैट इज कॉल्ड मेटाट्रॉनिक डिवाइसेस. आज डिस्कस एज वेणुगोपाल सर की इंजीनियरिंग, क्रिस्टल इंजीनियरिंग बहुत इंपॉर्टेंट है. तो क्रिस्टल इंजीनियरिंग का कहने का मतलब क्या है? क्रिस्टल इंजीनियरिंग कहने का मतलब ये है कि वी हैव मींस डेवलप द मटेरियल इन सर्टेन पीरियोडिक अरेंजमेंट. तो पीरियोडिक अरेंजमेंट जो सिस्टम होता है वो जनरली हम ये कहते हैं कि दैट इज कॉल्ड फोटोनिक. तो जनरली इलेक्ट्रोमैग्नेटिक वेव है क्या? तो इलेक्ट्रोमैग्नेटिक वेव जनरली एक तरह का लाइट है, एक रेंज तो एक्चुअली मैंने ऑलरेडी बताया कि इलेक्ट्रोमैग्नेटिक वेव ये वेव प्रोपोगेशन वेक्टर है, उसके परपेंडिकुलर डायरेक्शन इलेक्ट्रिक फील्ड होगा या मैग्नेटिक फील्ड होगा। तो ये जो हमारी जो विजिबल रेंज है, ये विजिबल रेंज हमारे लिए इंटरेस्टेड है। व्हाई? बिकॉज इफ वी आर एबल टू फैब्रिकेट द सच टाइप ऑफ नैनो मटेरियल इन पीरियोडिक ऑर्डर, मींस क्रिस्टल इंजीनियरिंग के बेस पर पीरियोडिक ऑर्डर में इसको बना सके, तो दैट टाइम सच टाइप ऑफ मटेरियल जो हम डिजायर करना चाहते हैं, जो बनाना चाहते हैं, वो हमारे लिए इम्पोर्टेंट है। तो जनरली ये हम लोग ने बेसिक मीन्स बीएससी में हम लोग ने पढ़ा फिजिक्स में, रिफ्लेक्शन होता है, रिफ्रैक्शन होता है, डिफ्रैक्शंस होते हैं, इवन आपके मीन्स टोटल इंटरनल रिफ्लेक्शंस होते हैं, आपके उन टोटल मीन्स इंटरनल रिफ्लेक्शन में इवेंसेंट वेव भी होता है। तो ये सभी कैरेक्टरिस्टिक जो है हमारे ऑप्टिकल प्रॉपर्टी के कुछ मटेरियल, ऑप्टिकल प्रॉपर्टी ऑफ मटेरियल पे डिपेंडेंट है। तो जनरली ये जो आपकी कैरेक्टरिस्टिक प्रॉपर्टी है, जनरली स्कैटरिंग कैरेक्टरिस्टिक प्रॉपर्टी है, ये आपके इलेक्ट्रोमैग्नेटिक वेव के लिए बहुत इंपॉर्टेंट होता है। क्यों? कि सपोज करो कि ये ग्लास, दिस इज द ग्लास, ये ग्लास एक तरह का एमॉर्फस मटेरियल है, एंड सच एमॉर्फस मटेरियल इज इंटरैक्ट विद द इलेक्ट्रोमैग्नेटिक वेव, and due to electromagnetic interaction with electromagnetic wave, they create the certain dipole moment, and due to presence of that dipole moment, they have certain refractive index, and such refractive index जब generally हम क्या कहते हैं कि due to such type of refractive index, such material has a certain property. So now such property, if we are considering in the order of the microstructure or nanostructure, that time such type of scattering of light become very important. Okay, so such type of property generally described in several nanostructure materials, and such nanostructure material को generally हम लोग कहते हैं कि ये नैनो मटेरियल है जिनका ऑर्डर 1 नैनोमीटर से 100 नैनोमीटर के बीच में होता है। तो जनरली एक कैरेक्टरिस्टिक है, यदि सपोज करिए कि हमारे इलेक्ट्रोमैग्नेटिक वेव यदि प्रोपोगेट कर रहा है किसी मटेरियल पर, तो वो मटेरियल में एक तरह का ये आपका इंटरफेरेंस फिल्म दिखाई देता है, तो सब ये थिन फिल्म ऑफ इंटरफेरेंस हम लोग को ऑब्जर्व होता है, एंड दैट इज ड्यू टू इंटरफेरेंस विद इन द लेयर। क्योंकि ये जो थिन फिल्म है, सच थिन फिल्म हैज ए सर्टेन मींस रिफ्रैक्टिव इंडेक्स, and this refractive index is means exists between this two air interfaces, and due to their means interference of this surfaces, they have certain means such type of color. But what happen if we observe the such type of color? This is the peacock feather color, and ये peacock feather color आपका ये colorful क्यों दिखाई देता है? Because such peacock feather has a certain structure, and such type of structures are there is the microstructure of the such type of peacock feather. Similarly, we can see this butterfly has a such type of microstructure, and such this is germs, ये germs के कुछ ऐसे structures होते हैं, and this is the one type of bugs, and bugs के जो आप उनके means surface study किया जाए तो कुछ इस तरह के तो such type of structures are one type of periodic structure. And due to presence of the such type of periodic structure, they have a certain colors, and that is why this is a color, because such type of periodic structure create certain type of interference inside the material. So such interference material आपके ये colorful आपको दिखाई दे रहे हैं। तो first time these two peoples has proposed the concept of the photonic spin in 1987, and they have two experiments based on the Rayleigh proposal. Rayleigh says that a thin film creates certain color due to interference. If what happens if such thin film is if we arrange the such type of thin film in periodic wave, so that time such type periodic wave create a certain band gap, and such band gap is able to control the photonic band gap. I mean electromagnetic wave. Electromagnetic wave is a photon. That's why such type of material is called photonic material. And band gap created by the such type of periodic structure is called photonic band gap material. So after 1987, proposed by these two peoples, the photonic crystal, peoples are developed the different type of photonic crystal, 1D photonic crystal, 2D photonic crystal, 3D photonic crystal, different types of photonic crystal. But such type of photonic crystal are means motivated with the nature. Okay, but people's This is a John Maddox, the editor of the Nature. In 1990, after giving after developed the botanical concept by the Evolnovich and John. After that, this John Maddox has said, if only were possible to make material in which electromagnetically waves cannot propagate at a certain frequency, and all kinds, almost magic things would happen. Why these magic things happen? Because if we put periodic structure, that time they create the band gap. And such band gap can be tuned with the help of the, by change the material. And after that, people have done several type of structure, means experiment to control the electromagnetic wave. And they fabricate artificially one-dimensional material, two-dimensional material, three-dimensional material, just like this one. This is a one-dimensional material, this is a two-dimensional material, and this is a three-dimensional. Why we are saying one-dimensional? Because this periodicity along one direction only. And why we are saying this is two-dimensional? Because this periodicity in two directions. And why we are saying this is a three-dimensional? Because such type of material are periodic in three dimensions. So such material has band gap. But me suppose if we are consider just like a glass, this is a glass, and if we take a certain glass, and in such glass has no any type of periodicity, and due to absence of periodicity there is no type of band gap. But if we repeat the such type of material, if we repeat the such type material, that time we create the such type of band gap. And this band gap is important as said by the John Maddox. Because according to John Maddox, this all kind almost magical things would happen due to this variation of band gap. And such band gap is very important. And what is different between this band gap? That is called photonic band gap. Why? Because this band gap is able to control the electromagnetic wave. So that's why this is called photonic. So generally, there are two types of band gap is considered. One is the electronic band gap, and other is the photonic band gap. What is mean by the electronic band gap? Electronic band gap is categorized as a band gap associated with the matter particle, means electron. But photonic band gap is characterized as a band gap associated by the field particle. Why? Because electromagnetic wave is a field wave. Because there is electric field and magnetic field coupled to each other along the propagation of the wave propagation direction k. So that's why there is a different. What is difference between this electronic band gap and photonic band gap? Generally, electronic band gap is parabolic nature. This is one type of parabolic nature. But other hand, photonic band gap is a one type of linearly dependent structure. And these band gap is created due to their periodicity of the material. Just like in this electronic band gap, there are certain electric potential repetition of the electric potential, and due to influence of that electric potential, they create the such type of electronic band gap. And such band gap generally, this allowed band gap is considered as a conduction band, and upper band is generally lower band is considered as a valence band, and upper band considered as a conduction band. And between this conduction band and valence band, that is a certain band gap. And such type of band gap created generally due to such type of periodicity. And based on this periodicity, we can consider two type of property. One is their dispersion relation, that is called band gap, and such band gap is equivalent to this transmission of the light. Because in electromagnetic wave, there are three type of property only possible. One is transmitted light, other is the reflected light, and third one is the absorption light. And these, on the basis of this dispersion relation as well as the transmission, both are same. Means where transmission is zero, it means that is a higher reflectance are there. But where the transmission is not zero, it means that waves are propagating from that means medium. So such type of property generally considered, and based on this property, we have we have solved these equations. And as I discussed earlier, this is the refractive index of the material, and this refractive index material is depend upon two parameters. One is the electric permittivity, other is the magnetic permeability. And these two parameters, if we are able to change these two parameters, we can change this refractive index. And after considering such type of property, first time two person means the first time we have described that is a negative index material. And such negative material, what is negative index material? That if this mu r means magnetic permeability and electric permittivity both are negative, that time this refractive index may be negative. And what happens when this n is negative? जब n नेगेटिव होगा तो क्या होगा? बिकॉज दिस n जो होता है, मैंने आपको ऑलरेडी बताया कि इलेक्ट्रोमैग्नेटिक वेव जब प्रोपोगेट करती है, प्रोपोगेशन जो वेक्टर होता है दैट इज रिलेट विद द देयर ऑप्टिकल डेंसिटी. तो दैट ऑप्टिकल डेंसिटी आपका क्या होगा? n होगा. और जो वेव प्रोपोगेशन k होता है दैट इज रिलेटेड विद द n. नाउ सपोज n की वैल्यू नेगेटिव होता तो क्या होगा? तो मान लीजिए वेव इस साइड प्रोपोगेट कर रहा हो, n की वैल्यू नेगेटिव हो जाए तो वेव आपका क्या होगा? अपोजिट डायरेक्शन में प्रोपोगेट करेगा. तो क्या होगा यदि मैं जनरली ये हम लोग एक्सपेरिमेंट करें तो P मींस पॉजिटिव इंडेक्स मटेरियल मींस एप्सिलॉन r, दिस एप्सिलॉन r एंड म्यू r दोनों नेगेटिव हो तो जनरली आपका कुछ ऐसा दिखता है. आप घर में भी एक्सपेरिमेंट कर सकते हो. ग्लास लीजिए, पेंसिल डालिए तो आपका कुछ स्ट्रक्चर आएगा. लेकिन व्हाट हैपन व्हेन n इज नेगेटिव? n को यदि नेगेटिव कर दिया जाए तो क्या होगा? ये एक तरह का आपका ये रिवर्स डायरेक्शन में होने लगे. तो ये रिवर्स डायरेक्शन में होने का मतलब क्या हुआ? बिकॉज वेव इज प्रोपोगेटिंग इन अपोजिट डायरेक्शन. तो कहने का तात्पर्य ये हुआ कि हम यदि नेगेटिव इंडेक्स मटेरियल में बना लूं तो क्या हो सकता है? हर वेव को हम नेगेटिव कर सकते हैं, मीन्स अपोजिट डायरेक्शन में वेव प्रोपोगेट करा सकते हैं. तो ये वेव प्रोपोगेशन के बेस पर हम लोग ने बहुत सारे ऐसे माइक्रो मीन्स नेगेटिव इंडेक्स मेटा मटेरियल बना लिए हैं जिनके कारण हम क्या कर सकते हैं? वी कैन कंट्रोल द इलेक्ट्रोमैग्नेटिक वेव. जनरली आप लोग ने देखा होगा हमारे मोबाइल में, हम यदि किसी मीन्स अपार्टमेंट के ग्राउंड फ्लोर में आप रहें तो आपका जो एंटीना होता है वो जनरली वर्क नहीं करता. क्यों नहीं वर्क करता? क्योंकि दोज एंटीना इज बेस्ड ऑन द ऑक्साइड मटेरियल. तो ये जो ऑक्साइड मटेरियल होते हैं ये पीम होते हैं, पॉजिटिव इंडेक्स मटेरियल होते हैं. तो ये जो पॉजिटिव इंडेक्स मटेरियल जो होते हैं, जो आपके बिल्डिंग्स में जो रॉड्स लगे हैं वो जनरली उन वेव को एब्जॉर्ब कर लेते हैं. लेकिन मान लेते हैं कि हमने उस मीन्स ऑक्साइड मटेरियल की जगह, एंटीना की जगह पे यदि मैं नेगेटिव इंडेक्स मटेरियल मैं उसमें इंप्लीमेंट कर दूं तो होगा क्या? ये वेव अपोजिट डायरेक्शन में प्रोपोगेट करेगा. तो अपोजिट डायरेक्शन प्रोपोगेट करने पर क्या होगा कि आपकी इंटेंसिटी यदि आपकी टावर की इंटेंसिटी यदि आपकी इंटेंसिटी बहुत लो भी हो तो वो रिवर्स डायरेक्शन में उसकी वेव की इंटेंसिटी को बढ़ा देगा. तो इसलिए आजकल बहुत सारे आपके नेगेटिव इंडेक्स एंटीना आ रहे हैं जिसको मेटा मटेरियल एंटीना भी कहा जाता है. तो अब जो मेटा मटेरियल जो एंटीना हम लोग के बने हैं वो जनरली माइक्रोवेव रीजन में ही बने हैं. वाई? बिकॉज हमने आपको बताया कि मेटा मटेरियल जो होता है वो पीरियाडिक अरेंजमेंट ऑफ द मटेरियल है. और पीरियाडिक अरेंजमेंट करना माइक्रोवेव में मीन्स मिलीमीटर ऑर्डर में हमें बहुत आसान है. जैसे पहली बार डी.आर. स्मिथ और जे.वी. पेंड्री ने माइक्रोवेव स्ट्रक्चर को उन्होंने बनाया क्या कि उन्होंने एक तरह का ये रॉड लिया और एक इन्होंने ये स्प्लिट रिंग रेजोनेटर लिया और इन दोनों को कंबाइन किया. तो इससे क्या हुआ? इससे ये हुआ कि आपका एप्सिलॉन आर की वैल्यू नेगेटिव हुआ और इससे क्या हुआ? म्यू आर की वैल्यू नेगेटिव हुआ. तो ड्यू टू दिस एप्सिलॉन आर नेगेटिव एंड म्यू आर नेगेटिव एंड सच टाइप ऑफ कंपोजिट मटेरियल, this has the negative index material. But there are several other materials also exist and that is called meta material. Just like this one, this is along the y-axis, this is the mu means magnetic permeability and this is the epsilon, this is the electric permeability and electric permeability ये दोनों positive हों तो that time this is called dielectric material. But when both are negative, that is called negative index material. What happens when someone means the epsilon is negative but mu is positive? And what happens when epsilon is positive but mu is negative? And such type of material is considered as a metamaterial. So it means besides this negative metamaterial, negative index material, there are other material also exist. And such type of material is considered as a metamaterial. And such metamaterial has two type of property. One type of property when we are discussing at a diffraction grating means periodic, we are considering for the periodic structure. And these periodic structure has the this D means separation between these two atoms. जो दो आयंस हैं, जो पीरियोडिक लेयर्स हैं, उनके बीच की डी की डिस्टेंस यदि लैम्डा के बराबर होगा, ये ग्रेटिंग के इक्विवेलेंट होगा. लेकिन व्हाट हैपन व्हेन दिस डी इज लेसर देन लैम्डा, तो ये जो कंसीडर होता है, इनको हम लोग बोलते हैं सब वेवलेंथ. सब वेवलेंथ या इसको हम लोग बोलते हैं मेटा सरफेस. एंड सच मेटा सरफेस की कैरेक्टरिस्टिक बहुत इंपॉर्टेंट होता है व्हेन वी आर कंसिडरिंग न्यू टाइप ऑफ मटेरियल दैट इज कॉल्ड हाइपरबोलिक मेटा मटेरियल. बिकॉज अकॉर्डिंग टू जनरल कैरेक्टरिस्टिक ऑफ द एनोसोट्रोपिक मटेरियल, जनरली मटेरियल जो है दो तरह के हम क्लासिफाई कर सकते हैं. जैसे ये ग्लास है, दिस ग्लास इज आइसोट्रोपिक मटेरियल. What is meant by the isotropic material? Means wave propagation along the x-axis, y-axis and z-axis is same. That time we say this is isotropic material. But what happen when their x-axis, y-axis, z-axis तीनों equal ना हो, तो उस समय इसको बोलते हैं anisotropic. So in anisotropic material we have two type of characteristics. One is the one-fold hyperbolic. In one-fold hyperbolic में क्या हो रहा है? This epsilon x and epsilon y both are negative, but epsilon z is not negative. What happen when epsilon z is negative? ठीक है, तो ये epsilon z को नेगेटिव कर दिया जाए, तो इनको हम लोग बोलते हैं टू फोल्ड हाइपरबोलिक. तो सच टाइप ऑफ मटेरियल, अब क्या है, एप्सिलॉन नेगेटिव हुआ, तो एप्सिलॉन नेगेटिव होने का मतलब क्या हुआ कि we have the means the property of the hyperbolic metamaterial. Sorry, metamaterial means metamaterial property. But such metamaterial property is considered with the help of this epsilon z negative or epsilon x and epsilon y negative in the form of the one or twofold. That time such type of material is called hyperbolic metamaterial. So such hyperbolic metamaterial become very important to synthesize the nano capacitor, nano means resistance and nano inductance. And such nano inductance and nano capacitance is very important for optical means propagation inside the material. So that's why we have recently there are one type of material is called SBN material, and such SBN material has characterized by the two type of material. One is type 1 HM, type 1 HM, that is where epsilon x is lesser than 0, epsilon y is lesser than 0. And type 2 material is that where epsilon z is 0, but epsilon x and epsilon o both are positive. So such type of material become very important, and due to development of the nanoscience and nanotechnology, today we are able to control the electromagnetic wave with the help of this type 1 and type 2 material. And with this type 1, type 2 material, there are several, this is the same thing. There are several material has been developed based on their nanoscience and nanotechnology. One is a graphite that is in UV zero, and magnesium dibromide that is for the visible region. Hexaborate nitrate जैसा अभी हमने बात किया, that is a mid infrared. HBN is type 1, type 2, इसको हमने बात किया, इसमें type 2, type 3. So there are several type of this hyperbolic metamaterial are fabricated, and such hyperbolic metamaterial are considered in the two types. One is when we are considering nanowire structure. In nanowire structure, we have the certain material, and such material is hosted with the certain dielectric material. But other hand is the thin film material, multi-layer structure, and such a multi-layer structure is hosted with the certain dielectric material. Dielectric material is the hosted of certain metallic material. So such type of multi-layer structure has both property. One is this epsilon r has a negative value, as well as sometimes they have the positive value when we have changed the value. This is the one type of characteristic property for the multi-layer film. Similarly, if we are considering for this nanowire structure, that time such nanowire structure has this epsilon value negative, as well as a certain wavelength they have epsilon is positive. And due to such type of characteristic property is based on their epsilon x, epsilon y, and epsilon z. So such type of material is very important, and there are several material have been developed.
5 minutes more.
Okay, sir. There are developed several multi-layer hyperbolic metamaterial based on range of the UV visible as well as the IR region. Now, Based on this epsilon value negative, and the epsilon x value negative, epsilon y value negative, or epsilon z value negative. That's why such type of characteristic can be used for the certain capacitance when this epsilon r is greater than 0. Means this epsilon is positive, that time that such type of lumps of the material, but such type of lumps of material must be lesser. This A means thickness of that material must be lesser than wavelength, incident wavelength. Such characteristic is called sub-wavelength property. And in sub-wavelength property, if we have calculated this epsilon is greater than 0, such type of material is equivalent to C. And when this epsilon is lesser than 0, means this is a negative value, that time such material is considered as a inductance. And when this epsilon imaginary value is not equal to 0, means they have a certain imaginary means absorption property is there, so that time such type of characteristic is considered as a resistance. Why we are discussing such type of property? In 2012, Nature publication, Sun has fabricated a devices, and he means proposed means based on the experiment, they have developed the such type of nanostructure, and based on this nanostructure, they have measured the electric field property in two directions. One is the in this direction, other is in this direction when their electric field is polarization is the perpendicular to the opposite direction. So that time, such type of characteristic property and such type of characteristic property has certain characteristic for the filter characteristic property, and such filter characteristic is considered as a pass band filter. And on the basis of this such type of structure, people are developed different type of material and try to develop such type of mechatronics device at in visible region. And based on this metamaterial, this hyperbolic metamaterial, we can develop the such type of LCR circuit for the optical region. Such type of material is very important, because if we are able to fabricate, I am doing theoretical work on the such type of such type of work, but I am continuously also working on experiment also based on their chemical method as well as the CVD method. And if we are able to develop such type of material in nano order, nano structure material, that time we can develop new type of LCR circuit at nanostructure, where we can control the optical property, and such optical property can be used in optical computing. And in optical computing, such type of material is very fruitful to control the propagation of photon in place of electron. Generally हम लोग जो आजकल इलेक्ट्रॉन को कंट्रोल कर रहे हैं, उसी तरह इन फ्यूचर वी हैव ऑप्टिकल कंप्यूटर होगा, ऑप्टिकल कंप्यूटिंग होगा, वेयर वी आर एबल टू कंट्रोल द फोटोन. हम लोग जानते हैं कि आपने देखा होगा ऑप्टिकल फाइबर जो है, ऑप्टिकल फाइबर क्या करता है, वी कंट्रोल द फोटोन. Optical fiber हम लोग क्या करते हैं, we control the photon with the certain fiber communication system. Similarly, if we are able to control the photon with the help of this LCR circuit, that time we can develop the optical computing. And generally ये मेरे मित्र हैं Dr. Vijay Snanath Pandey. He always motivate to work in this direction. मेटा मटेरियल पे मैं काम कर रहा हूँ, या मेटा मटेरियल में जो भी मैंने पेपर पब्लिश किए हैं, इनकी मोटिवेशन से हुआ है, और इनके मोटिवेशन से मैंने बहुत सारे काम किए हैं, और इनको मैं थैंक्स करना चाहता हूँ. लास्ट में आई आल्सो थैंक्स टू देवेंद्र सर, ये जो मेरे साथ आए हैं, उनका सपोर्ट, और मेरे ये गुरुदेव हैं. मैं स्पिरिचुअल रामचंद्र मिशन से जुड़ा हूँ, तो मेरे ये कमलेश जी पटेल हैं, जो प्रेसिडेंट है रामचंद्र मिशन के शाहजहांपुर यूपी के. और ये थैंक यू फॉर योर काइंड अटेंशन. इफ यू हैव एनी क्वेश्चन, आई ट्राई टू एक्सप्लेन, ट्राई टू आंसर योर क्वेश्चन.
Any question from student?
देखो स्टूडेंट, यदि ये पीपीटी मैं यहाँ दे दूंगा, आप लोग देख लीजिए, लेकिन पीपीटी आपको देने से कोई फायदा नहीं है जब आप कुछ क्वेश्चन ना पूछें. हाँ,
Sir, basically in layman language, how can we see that these hyperbolic metamaterials can be helpful in nanotechnology? Just in simple language, how can we see that?
Other is the non-linear material. Okay. In linear material, generally, wave propagation along the x-axis, y-axis, z-axis, both are same. Okay. In all directions, they are same. But in anisotropic material, their direction is different. ठीक है. तो जो मैंने यहाँ डिस्कस किया वो यूनिएक्सियल मटेरियल. यूनिएक्सियल मटेरियल मीन्स इन जेड डायरेक्शन देयर प्रॉपर्टीज डिफरेंट, बट एक्स एंड वाई डायरेक्शन दे आर सेम एंड different. But now, if we are able to produce such type of material having that epsilon x and epsilon y are is lesser than zero, so that time such type of material is called one type of hyperbole. But such type of material means already exists in graphene. Means graphene as well as HBN means hexagonal boronitride. Such type of material already exists a hyperbolic characteristic. If we have suppose if we have developed the graphene in one or two structure, that time such type property already exists. That's why in nanostructure material we can develop such. ओके. तो मीन्स ग्राफिन मटेरियल हुआ या एसबीएन हुआ. एसबीएन जो फर्स्ट मटेरियल है जिसमें हाइपरबोलिक कैरेक्टरिस्टिक दिखाई दिया. बट टुडे पीपल्स आर डेवलप means graphene material with the certain functionalized property, like वो HBN means graphene को कोई कॉपर के साथ फंक्शनलाइज कर रहे हैं, कोई जिंक के साथ फंक्शनलाइज कर रहे हैं. तो फंक्शनलाइज करके उनको हम एक तरह का एनोसोट्रोपिक मटेरियल बना सकते हैं हैविंग सच टाइप ऑफ हाइपरबोलिक मटेरियल. एंड पीपल्स आर डेवलपिंग. जैसे मैंने आपको बताया यहाँ पर ऑलरेडी कुछ जैसे जिंक ऑक्साइड है और फिर आपका मैग्नीशियम ऑक्साइड है, इनकी यदि नैनो स्ट्रक्चर बनाया जाए और सिंगल स्ट्रक्चर एक पीरियडिक बनाया जाए तो उसमें हाइपरबोलिक मिलती है. और कोई क्वेश्चन? थैंक यू फॉर योर काइंड अटेंशन एंड पेशेंस के साथ सुनने के लिए. थैंक यू.
इस तरीके से ये हमारा टेक्निकल सेशन समाप्त होता है. अब हम जो है कुछ हमारे डेलीगेट्स हैं जिनका फेलिसिटेशन छूट गया था हम लोगों से, तो अब मैं उस कड़ी में बुलाना चाहूँगा डॉक्टर देवेंद्र प्रताप मिश्र जी, असिस्टेंट प्रोफेसर, गवर्नमेंट इंजीनियरिंग कॉलेज, अम्बेडकर नगर. प्लीज़ कम ऑन द डायस. और इनके फेलिसिटेशन के लिए मैं डॉक्टर सदगुरु प्रकाश जी को आमंत्रित करता हूँ. अब मैं इनवाइट करूंगा डॉक्टर मनीष गुप्ता, असिस्टेंट प्रोफेसर, जेपी यूनिवर्सिटी छपरा. इनके फेलिसिटेशन के लिए मैं डॉक्टर बसंत कुमार, असिस्टेंट प्रोफेसर केमिस्ट्री, बुलाना चाहूँगा. डॉक्टर ऋषि, you accompany him. डॉक्टर देवेंद्र प्रताप मिश्र जी, कंपनी। हाँ, अब महाविद्यालय के श्री अभिषेक सिंह, जिन्होंने 4-5 दिन हो गया लगातार मुस्तकिल इसमें टेक्निकल काम में लगे हुए हैं, मैं उनको बुलाना चाहूँगा। श्री अभिषेक सिंह, असिस्टेंट प्रोफेसर, बीसीए, डिपार्टमेंट MLK। अभिषेक जी का फेलिसिटेशन होगा और डॉक्टर ऋषि रंजन पांडे जी करेंगे। डॉक्टर जितेंद्र यू आल्सो ए कंपनी। अब 2 लोग और हैं जिन्होंने कल से बहुत ज़्यादा काम किया। मैं सबसे पहले बुलाना चाहूँगा योगेश शुक्ल जी को। वो अभिषेक जी के साथ ही लगे रहे कंटिन्यूअस। और इनके फेलिसिटेशन के लिए हम बुलाना चाहेंगे डॉक्टर अरुण कुमार, असिस्टेंट प्रोफेसर केमिस्ट्री। प्रियांश पांडे जी, आप जो है ओरल प्रेजेंटेशन में और ऑनलाइन ओरल प्रेजेंटेशन में लगातार डॉक्टर ऋषि रंजन पांडे और डॉक्टर जितेंद्र कुमार के साथ लगे रहे। इनके फेलिसिटेशन के लिए मैं डॉक्टर अमित कुमार वर्मा जी को बुलाना चाहूँगा। खड़े हो जाओ रोशन जी, कंपनी। अब कॉन्फ्रेंस की रिपोर्ट प्रस्तुत हो इससे पहले मैं मोस्ट रिस्पेक्टेड प्रोफेसर देवेश कुमार साहब से अनुरोध करूंगा कि वो इस कॉन्फ्रेंस के बारे में 2 शब्द बोलें। वहीं से बोल दीजिए।
सबसे कठिन कार्य होता है कुछ बोलना, लेकिन मैं 2-3 बातें बोलूंगा जरूर। पहला चीज है कि जैसे ये कॉन्फ्रेंस है, इंटरनेशनल कॉन्फ्रेंस ऑन मल्टीफेसेट एप्लीकेशन ऑफ केमिकल साइंस। मुख्य चीज है कि किसी भी कॉन्फ्रेंस को कराने के लिए उद्देश्य क्या है। 10 लोग बैठे, कुछ स्लाइड प्रेजेंट कर दिए, ये पर्पज नहीं होता। इसका मुख्य पर्पज जो कॉन्फ्रेंस का किसी भी शिक्षण संस्थान में जो कराया जाता है ये होता है कि स्टूडेंट ज़्यादा से ज़्यादा आए और देखें कि इस पर्टिकुलर दिशा में किस किस तरह का कार्य हुआ है, क्या क्या डेवलपमेंट हुआ है और क्या डेवलपमेंट होना बाकी है। क्योंकि अब आप लोग सभी लोग एनईपी सिस्टम के विद्यार्थी हैं और एनईपी में रिसर्च पे ज़्यादा जोर दिया गया है, प्रोजेक्ट है। ये और बात है कि आप लोग उसको मार्क्स पाने का जरिया समझ लिए हैं कि गुरु जी खुश होंगे, नंबर दे देंगे, ये दूसरी बात है। लेकिन इस कॉन्फ्रेंस से अगर एक लड़का भी रिसर्च के प्रति मोटिवेट हो गया तो ये मान लिया जाएगा कि ये कॉन्फ्रेंस सफल रहा। अंसारी जी अब बस कर दें।
हो गया सर।
ओके, धन्यवाद।
थैंक यू सर। अब एक बहुत डिफिकल्ट काम प्रस्तुत करना है, रिपोर्ट ऑफ द कॉन्फ्रेंस। इसको प्रस्तुत करेंगे केमिस्ट्री डिपार्टमेंट के असिस्टेंट प्रोफेसर डॉक्टर बसंत कुमार। डॉक्टर बसंत कुमार।
थैंक यू वेरी मच सर। हम सबके बीच मंच पर उपस्थित प्रोफेसर देवेश कुमार सर, प्रोफेसर सरोज कुमार शुक्ला सर, डॉक्टर केम थापर सर, प्रोफेसर देवेंद्र सिंह सर, रंजन बसाक सर, देवेंद्र मिश्र सर, अन्य बाहर से आए हुए अतिथिगण, इस कॉन्फ्रेंस के कन्वीनर प्रोफेसर आर.के. सिंह सर, विभागाध्यक्ष फिजिक्स प्रोफेसर ए.के. द्विवेदी सर, विभागाध्यक्ष गणित प्रोफेसर वीना मैम, पॉलिटिकल साइंस डॉक्टर प्रखर त्रिपाठी सर, अंसारी सर, सदगुरु प्रकाश सर और राम आश्रय गौतम सर और बॉटनी विभाग से वी.के. सिंह सर और अन्य यहाँ पे उपस्थित सभी प्राध्यापक गण का मैं हार्दिक अभिवादन करता हूँ और सबका सम्मान करता हूँ, स्वागत करता हूँ। मैं इस 2 दिवसीय अंतर्राष्ट्रीय कॉन्फ्रेंस जिसका विषय मल्टीफेसेटेड एप्लीकेशन ऑफ केमिकल साइंसेज है की समरी प्रस्तुत कर रहा हूँ, जो कि कुछ इस प्रकार है। इस कॉन्फ्रेंस का शुभारंभ कल 30 मार्च को लगभग 11 बजे माँ सरस्वती के प्रतिमा पर माल्यार्पण व दीप प्रज्वलन के द्वारा प्रारंभ हुआ। इसके पश्चात महाविद्यालय के कुलगीत के द्वारा इसका शुभारंभ हुआ। इस कॉन्फ्रेंस में आए हुए अतिथियों का महाविद्यालय के प्राचार्य प्रोफेसर जे.पी. पांडे सर ने स्वागत किया व कॉन्फ्रेंस के थीम पर प्रकाश डाला। तत्पश्चात इस कॉन्फ्रेंस के कोऑर्डिनेटर प्रोफेसर अंसारी सर द्वारा कॉन्फ्रेंस के थीम पर अपने विचार व्यक्त किए गए। इसके अगले क्रम में अतिथियों व सभी आयोजन समिति के सदस्यों द्वारा कॉन्फ्रेंस के सेमिनार का विमोचन किया गया। तत्पश्चात महाविद्यालय के प्रबंध समिति के सचिव लेफ्टिनेंट कर्नल आर.के. मोहंता सर द्वारा कॉन्फ्रेंस की सफलता हेतु शुभाशीष दिया गया। इसके अगले क्रम में जीसा सेक्रेटरी प्रोफेसर सुनीता आर्या द्वारा जीसा के विषय में जानकारी प्रदान की गई व कॉन्फ्रेंस हेतु शुभकामनाएं दी गई। इसके अगले क्रम में प्रोफेसर ए.के. वर्मा सर, जो कि चीफ गेस्ट के रूप में उपस्थित हुए थे, ने थीम के अर्थ व विद्यार्थियों को विज्ञान के प्रति जागरूक होने के लिए प्रोत्साहित किया। तत्पश्चात प्रोफेसर संदीप सिंह सर, आप इस कॉन्फ्रेंस के अध्यक्ष के रूप में यहाँ पर उपस्थित थे, आपने अपना उद्बोधन दिया। इसके अगले क्रम में जीसा के द्वारा महाविद्यालय के सचिव मोहंता सर को सरदार पटेल ग्लोबल अवार्ड व ज्वाइंट सचिव वी.के. सिंह सर को डॉक्टर सर्वपल्ली राधाकृष्णन अवार्ड व डॉक्टर अनुपम पति त्रिपाठी एचआरपीजी कॉलेज को बेस्ट टीचिंग फैकल्टी अवार्ड द्वारा सम्मानित किया गया। अगले क्रम में कॉन्फ्रेंस के कीनोट स्पीकर प्रोफेसर प्रेमराज सर, आप लखनऊ विश्वविद्यालय से बिलोंग करते हैं, ने रोल ऑफ मेटल्स व टॉक्सिसिटी ऑफ मेटल्स पे बड़े विस्तार से अपने विचारों को प्रस्तुत किया। प्रथम दिन के प्रथम तकनीकी सत्र का शुभारंभ प्रोफेसर संदीप सिंह आईआईटी रुड़की के व्याख्यान से प्रारंभ हुआ। आपने अपने उद्बोधन में रेडियो एक्टिव डीके से रॉक्स के एज को कैलकुलेट करने के विषय में विस्तार से बताया गया। इसी के साथ प्रथम दिवस में लंच को आयोजित किया गया। लंच के ब्रेक के पश्चात द्वितीय तकनीकी सत्र प्रारंभ हुआ, जिसमें प्रथम वक्ता लखनऊ विश्वविद्यालय के प्रोफेसर RM नायक सर रहे। नायक सर ने नैनो मटेरियल सिंथेसिस व इसके काइनेटिक्स और मैकेनिज्म पर विस्तार से अपना विचार रखा गया। तत्पश्चात डॉक्टर तौकीर अहमद खान जर्मनी से इनका व्याख्यान हुआ। आपने ऑनलाइन अपने व्याख्यान को प्रस्तुत किया। इसी क्रम में तीसरे वक्ता डॉक्टर V रामनाथन सर IIT BHU रहे। इस तत्पश्चात डॉक्टर आशुतोष सर IIT हैदराबाद, डॉक्टर संतोष कुमार हिमाचल प्रदेश, मोहम्मद अल्ताफ हुसैन जापान, आप लोगों का भी व्याख्यान संपन्न हुआ। कॉन्फ्रेंस के प्रथम दिवस में ही पोस्टर सत्र का भी आयोजन किया गया, जिसमें प्रोफेसर नायक सर, प्रोफेसर आशुतोष सिंह सर आदि के पैनल के द्वारा सभी पोस्टरों का मूल्यांकन करके प्रतिभागियों को प्रथम, द्वितीय और तृतीय पुरस्कार से भी सम्मानित किया गया। कॉन्फ्रेंस के प्रथम दिवस में ही ऑफलाइन समानांतर सत्र भी आयोजित किया गया, जिसमें अनेक प्रतिभागियों द्वारा अपने शोध पत्रों का प्रस्तुतिकरण किया गया। इस सत्र को डॉक्टर जितेंद्र सर और डॉक्टर ऋषिनंदन पांडे सर ने साइकोलॉजी विभाग में आयोजित करवाया। कॉन्फ्रेंस के दूसरे दिन आज प्रथम वक्ता के रूप में डॉक्टर तनवीर अहमद खान सर USA से आपके व्याख्यान के द्वारा शुभारंभ हुआ। इसी के साथ आज सुबह अन्य प्रतिभागियों द्वारा ऑनलाइन समानांतर सत्र में भी प्रतिभाग किया गया, जो कि मनोविज्ञान विभाग में आयोजित किया गया। आज के दूसरे वक्ता प्रोफेसर हरिशरण मिश्रा सर फ्रॉम बार्क रहे। आपने इम्पैक्ट ऑफ गामा रेडिएशन ऑन बैक्टीरिया पर अपना व्याख्यान प्रस्तुत किया। तत्पश्चात डॉक्टर अदनान खान कनाडा ने अपने शोध पत्र का प्रस्तुतिकरण किया, जिसका विषय स्टील प्रोडक्शन इन कनाडा था। इसके अगले क्रम में डॉक्टर विक्रम सिंह धनबाद झारखंड सर का व्याख्यान रहा, जिसका विषय डेवलपमेंट ऑफ वाइट लाइट इमिटिंग मटेरियल था। इसी के साथ प्रथम तकनीकी सत्र का समापन हो गया। द्वितीय तकनीकी सत्र के प्रारंभ प्रोफेसर निजामुद्दीन सर DDU गोरखपुर विश्वविद्यालय के व्याख्यान से प्रारंभ हुआ। आपने क्लिक केमिस्ट्री विषय पर केंद्रित अपना व्याख्यान प्रस्तुत किया। तत्पश्चात डॉक्टर AN शुक्ला सर न्यू दिल्ली का व्याख्यान हुआ। इस कॉन्फ्रेंस के अगले वक्ता प्रोफेसर गोपालन सर केरला रहे। आपने अपने उद्बोधन में सुप्रामॉलिक्यूलर केमिस्ट्री से जुड़े सुप्रामॉलिक्यूलर सिंथेसिस व क्रिस्टल इंजीनियरिंग पर विस्तृत रूप से अपने विचार व्यक्त किए गए। इसके अगले क्रम में अगली प्रस्तुति रही प्रोफेसर सरोज कुमार शुक्ला सर, आप दिल्ली विश्वविद्यालय से बिलोंग करते हैं। सर का व्याख्यान कंडक्टिंग बायोपॉलीमर पर केंद्रित रहा, और इसके साथ ही आपने कंडक्टिंग बायोपॉलीमर के एप्लीकेशन पर भी विस्तार से चर्चा की। इस कॉन्फ्रेंस के अंतिम वक्ता डॉक्टर KMB थापा सर रहे। आप BBAU लखनऊ से बिलोंग करते हैं। आपका व्याख्यान ऑप्टिकल प्रॉपर्टी ऑफ मटेरियल विषय पर केंद्रित रहा। इस कॉन्फ्रेंस में अगर समराइज करके कहा जाए तो इस कॉन्फ्रेंस में लगभग 300 से अधिक प्रतिभागियों द्वारा ऑनलाइन व ऑफलाइन रजिस्ट्रेशन किया गया। इस कॉन्फ्रेंस के सविनियर के पब्लिकेशन हेतु लगभग 200 एब्स्ट्रैक्ट प्राप्त हुए, जिसका डॉक्टर जितेंद्र सर ने बड़ी मेहनत से उनका प्लेगरिज्म से लेकर सारी चीज़ें चेक किया और वो पब्लिकेशन हेतु आ गया है। इसके अतिरिक्त कॉन्फ्रेंस में ISBN नंबर युक्त बुक में पब्लिकेशन हेतु लगभग 40 बुक चैप्टर प्राप्त हुए, और इस इंटरनेशनल पब्लिकेशन के बुक का प्रकाशन अगले 15 अप्रैल तक संभावित है। इस कॉन्फ्रेंस के दोनों दिन में कुल मिलाकर 20 ऑफलाइन और लगभग 40 ऑनलाइन पैरेलल रिसर्च पेपर भी प्रस्तुत किए गए। इस कॉन्फ्रेंस में कुल मिला के लगभग 7 देशों व 15 प्रदेशों के विद्वानों द्वारा अपने शोध पत्रों का प्रस्तुतिकरण किया गया। इसके साथ ही समानांतर ऑनलाइन ऑफलाइन में प्रतिभागियों को प्रथम, द्वितीय और तृतीय अवार्ड से भी सम्मानित किया गया है। पोस्टर प्रेजेंटेशन हेतु लगभग 30 प्रतिभागियों ने प्रतिभाग किया था, जिसमें से कुछ नहीं आ पाए, लेकिन अधिकतर लोगों ने अपने प्रेजेंटेशन को प्रस्तुत किया। कुल मिला के पिछले 4 सालों से मैं इस महाविद्यालय में कार्यरत हूँ। मुझे पहला कॉन्फ्रेंस ऐसा लगा जो हर मामले में कंप्लीट रहा, इन द सेंस कि पोस्टर सेशन भी हुआ, पोस्टर सेशन भी हुआ, पैरेलल ऑफलाइन भी हुआ, पैरेलल ऑनलाइन भी हुआ, मेरे अपने हिसाब से, बाकी तो लोग जज करते हैं। इस कॉन्फ्रेंस के सफल आयोजन में सभी लोगों का बहुत सक्रिय योगदान रहा, स्पेशली हमारे विभागाध्यक्ष प्रोफेसर R.K. सिंह सर का। आपने इस कॉन्फ्रेंस के सफल आयोजन हेतु चूना छिड़कने से लेकर के ब्राउजर बनने से लेकर के साथ सज्जा, गेस्ट को आने, उनके रुकने, खाने पीने, हर चीज़ के इंतजाम में अपना क्रिटिकल व्यू प्रस्तुत किया, और इस वजह से हम लोग इसको इस मुकाम तक लेके आ पाए। सर आपके लिए सबसे कह दो कि आप ताली बजाएं। और अंसारी सर, आपको अंसारी सर के बारे में क्या कहना, हर चीज़ को बड़े सीरियस होकर करते हैं और बेचारे दिन रात मेहनत की। स्वास्तिक प्रिंटर के यहाँ भी बहुत मेहनत सर को करना पड़ा, मैं व्यक्तिगत रूप से जानता हूँ। इसके अलावा 2 दिन में सबके साथ हैंडलिंग कोऑर्डिनेट करने में सर ने बहुत मेहनत, तो सर के लिए भी। अगले क्रम में आयोजन सचिव सुनील सर, आपने भी इस बार बहुत ज़्यादा पेन लिया। और जितेंद्र सर, आपका तो स्वाभाविक है, आप पहले आयोजन सचिव नहीं थे, आप अब मैंने मेरे कहने के बाद आपका नाम इंट्रोड्यूस किया, आप बल्कि इस पर दुख व्यक्त कर रहे थे कि मुझे आयोजन सचिव क्यों बनाया गया, लेकिन मैंने कहा आपको काम करना ही है तो आपको आयोजन सचिव होना ही चाहिए। तो जितेंद्र सर के लिए भी है। ऋषि रंजन सर, आप मीडिया प्रभारी हैं, आपने भी ऑनलाइन और ऑफलाइन सत्र को आयोजित करने में, इसके अलावा भोजन की व्यवस्था देखने में अपना सहयोग प्रदान किया। कुल मिला के तकनीकी रूप से जुड़े हुए लोगों और यहाँ पे उपस्थित छात्र छात्राओं, बाहरी प्रतिभागियों, सभी को सम्मान देते हुए मैं अपनी वाणी को विराम देता हूँ। धन्यवाद सर, सबको बहुत बहुत धन्यवाद।
आप ही कुछ तो बसंत जी बोल गए हैं, डॉक्टर सुनील। अब वोट ऑफ थैंक्स होगा और इसको प्रस्तुत करेंगे केमिस्ट्री डिपार्टमेंट के असिस्टेंट प्रोफेसर डॉक्टर सुनील कुमार मिश्र। Thank you, Ansari sir. Distinguished guests, esteemed speakers, respected faculty members, dear delegates, and my dear students. As we draw the curtains on the International Conference on Multifaceted Applications of Chemical Sciences, ICMACS-2024, organized by Chemistry Department of M.L.K. PG College, Balrampur, in association with GESA, New Delhi. It's my privilege and honor to extend a heartfelt vote of thanks to all who have contributed to the success of this extraordinary event. First and utmost, I thanks to Managing Committee of the college. Without their support, it is not possible to organize such a conference. I express my sincere gratitude to our esteemed guests and speakers who graced us with their presence and shared their invaluable insights and knowledge. Your expertise has enriched our understanding and inspired us to strive for excellence in the field of chemical sciences. I express my special thanks to Professor Devesh Kumar, who joined us in spite of his very busy schedule, and Dr. Farhan Ahmad Pasha, who came here from Saudi Arabia to make this conference very meaningful. During the preparation of the conference, he contributed each and every moment whenever we talked to him for any suggestion and any solution. I also thanks Dr. D.P. Misra, Dr. Pushmit Misra, Dr. Manish Gupta, Dr. Ranjan Basak, and with apology because two speakers, Dr. Dattatreya Dhawale from Australia and Dr. Manoj Gupta from Central University of Haryana, Mahendgarh, whose invited talks were skipped due to some unavoidable problems. I extend my gratitude to all the participants, both speakers and attendees, for your active participation throughout provoking discussions and engaging interactions throughout the conference. Your enthusiasm and dedication have been instrumental in making this event a resounding success. I am deeply grateful to the organizing committee of this international conference under the dynamic leadership of Professor J.P. Pandey, our energetic principal, and Professor R.K. Singh, HOD Chemistry, Dr. Sadhguru Prakash, co-coordinator, Dr. M. Ansari sir, Dr. Basant Kumar, Dr. Jitendra Kumar, Dr. Ranjan Pandey, और इन्होंने जो मेहनत की प्रकाष्ठा की है उसको हम शब्दों में नहीं बांट सकते। बाकी आगे बढ़ते हैं। Your hard work and commitment ensured the smooth execution of ICMACS 2024, leaving an indelible mark on all who participated. I also thanks to Professor A.K. Dwivedi sir, Professor P.K. Singh sir, Professor Veena ma'am, Dr. Prakhar Tripathi, Dr. Mohammad Akbal, Dr. Raju Ranjan, and Dr. Bimal Prakash Verma, Dr. Prakash Misra. A heartfelt appreciation goes out to our sponsors, partners, and supporters for their generous contributions and unwavering support. Your collaboration has been pivotal in making this conference a reality and facilitating the exchange of ideas and knowledge among chemical sciences enthusiasts. I would also like to acknowledge the staff, volunteers, and technical team in leadership of Mr. Abhishek Singh, HOD BCA and Computer Science Department, whose behind the scene efforts have been crucial in ensuring the seamless execution of various activities and logistics throughout the conference. Special thanks to Abhijit Pandey, Priyansh Pandey, and Yogesh Misra for providing support in coordinating the parallel sessions. Last but not least, I extend my gratitude to the all faculty members, students, and staff of M.L.K. PG College for their continuous support in hosting the prestigious event. I thanks to Mannuji and his son Janmej for delicious breakfast and lunch. I thanks Bhavana Studio for taking pictures of the event and making the event a memorable one. I want to thank my organizing team for working together to make this conference a successful event. A big thanks to media persons Ajit Shukla ji, Akhleshwar Tiwari ji, and our college media in charge Dr. Devendra Kumar Chauhan for spreading the news of event of this conference among people. इसके अलावा मैं रसायन विज्ञान विभाग के नॉन टीचिंग स्टाफ रणबीर सिंह, दिनेश प्रसाद, संतोष सिंह, शिव प्रसाद, लाइब्रेरी को देख रेख करने वाले गजानन पांडे और हर जगह हर समस्या के समाधान के लिए उपलब्ध संतोष यादव जी और इलेक्ट्रीशियन अटल और गयास, और इसके साथ साथ मैं कॉलेज के सिक्योरिटी गार्ड्स को भी बहुत बहुत धन्यवाद ज्ञापित करता हूँ. Thank you once again. But before conclusion, I express my sincere thanks to all the PG students of our college for their tireless support. At last, I thank you once again to everyone who contributed to the success of this conference. Your dedication and commitment have made ICMAC 2024 an unforgettable and enriching experience to all. Best wishes for continued success and innovation in the field of chemical sciences with warm regards. अंत में जिसका नाम नहीं ले पाया हूं, जो इस आयोजन में प्रत्यक्ष या अप्रत्यक्ष रूप से किसी भी प्रकार से जुड़े रहे, सबके प्रति अपने धन्यवाद ज्ञापित करता हूं. बहुत बहुत धन्यवाद.
इसके बाद ग्रुप फोटोग्राफी के लिए मैं अपने थैंक यू. उस छोटी सी प्यारी सी बच्ची को भी धन्यवाद. और गौरी मैडम ने इस कंडीशन में भी हम लोगों का बहुत सहयोग किया, लगातार वहाँ प्राइज डिस्ट्रीब्यूशन में लगे रहे. बहुत बहुत धन्यवाद मैडम. ग्रुप फोटोग्राफी के लिए मैं अपने सभी गेस्ट और प्रोफेसर टीचर्स से अनुरोध करता हूँ कि आप लोग स्टेज पर आ जाए. हमारे इधर आ जाए सब लोग.
कर दिया जाए. म्यूजिक बजाना, म्यूजिक प्ले करेंगे, म्यूजिक का निकल.
दिवसीय अंतर्राष्ट्रीय सेमिनार का समापन होता है। बहुत बहुत धन्यवाद।